Hello, this is Systems of Linear Equations and Inequalities, solving systems of linear equations in three variables, example 1. And here I have a system of three equations with three variables, and we're going to solve it. And the trick is to take this system and come up with a system of two equations and two unknowns. So I'll do that first by taking the first two equations and eliminating a variable, and then taking the second two equations and eliminating the same variable. So looking at the first two equations, if I multiply the second equation by 2 and then add it to the first equation, that would get rid of the y's, because I'd have negative 2y plus a positive 2y, and that adds to 0. So I'll multiply the second equation by 2. Okay, now I'm going to add these two equations together. This new equation is equivalent to the second equation. Adding it to the first equation, I get 7x, the y's cancel, and plus 10z equals 19. So this is one of the equations that I'll be working with. And now to get the second equation, I'm going to work with the bottom two equations and try to eliminate the y. I eliminated the y to get this. Now I have to do that again with these two equations. And here I'm trying to eliminate the y. So if I multiply the top equation times negative 3, that'll make this positive 3y and negative 3y, and those will cancel out. So I'm multiplying this times negative 3. So this is negative 6x plus 3y minus 9z equals negative 12. Okay, now I will add, now I have this equation which is equivalent to this one, and I'm adding it to this one. So here I end up with negative x, the y's cancel, minus 4z equals negative 13. So this is the second equation that I'm working with. So I have these two equations. And now I'll solve these two equations, and I'll have x and z. So these are the two equations that I need to solve. And now looking these over, it looks like if I multiply the top one times 7, then the x's will disappear. So multiplying the top one by 7, I have negative 7x minus 28z equals, let's see, negative 91. So now this equation is equivalent to this one. I just multiplied by 7. And now I can add these two together, and I end up with negative 18z equals whatever 91 take away 19 is. Let's see, that's 2. I borrowed 1. That's negative 72. So if negative 18z is equal to negative 72. Now, when I divide both sides by negative 18, I get z is equal to 4. So z is equal to 4, and let's try substituting into this first equation. So getting that ready for substitution, it's negative x minus 4 empty parentheses equals negative 13. Z is equal to 4. So minus x minus 16 equals negative 13. So now I'm going to add 16 to both sides, and I get negative x is equal to positive 3, or x equals negative 3. So these are two parts of the solution, z equals 4 and x equals negative 3. So now I'm going to substitute z equals 4 and x equals negative 3 into one of my original equations here. And I'll just use the top equation, getting this ready for substitution for the x and the z. And the x is negative 3 and the z is 4. So this is negative 9 plus 2y plus 16 equals 11. So now like terms, the negative 9 and the positive 16, that adds up to positive 7. And now subtracting 7 from both sides, I end up with 2y equals 4, or y equals 2. So this is the solution. The solution is x equals negative 3, y equals 2, and z equals 4.